Notes solving systems by elimination day 1. All right, so the goal with elimination, okay, is 0 pairs. 0 pairs. Okay. If we see a 0 pair, that's great. Now what I mean by 0 pair is like 2x and negative 2x. Positive y, negative y. Things like that. We want a term to cancel out. Okay, now the way that we know these are set up, that something's set up for elimination, is when you look at it and you see this. Positive y, negative y. We have a 0 pair. That's how we know. So our first step, okay, our first step is going to actually be to add these together. That may seem a little weird at first, but that's what we're going to do. So x plus x is 2x. Positive y, negative y cancels out. And 5 and negative 1 is 4. We can solve this equation really easy. Dividing by 2, we have x equals 2. Okay? X equals 2. This is kind of similar to what we had before. X equals 2, so 2 comma something. All right, now here we need to pick one of the equations. I am going to always go with the first one just because I'm just going to do that just because it's almost always easier not to have to think about it. Take that first one. So x plus y equals 5. If x is 2, okay, if x is 2, this is 2 plus y equals 5. So if I subtract 2 from both sides, I get that y equals 3. So therefore our answer is 2 comma 3. Okay? Again, look for the 0 pair. That's how your job gets easy. Number 2, do you see a 0 pair somewhere? You ought to right here, same place, positive y, negative y. When we add these two equations together, we're going to have 3x equals 15. There's our first step. So dividing by 3, x equals 5. So in our solution, we have 5 comma something. All right, step 2, take the first equation, x plus y equals 11. Well, if x is 5, then let's subtract 5 from both sides. We get that y equals 6. So our ordered pair is 5 comma 6. All right, now if you notice, there's a lot less work than there was in the previous days with substitution. The point is, there are some systems that are easier to solve with substitution than they are with elimination. There are also a lot like this that it's easier to find a 0 pair and use elimination than it is for substitution. And at some point, it'll really be up to you. Whichever one is the easiest to go with, do it. Okay? All right, let's move on to number 3. We're looking for 0 pairs. I see it right here. Negative 6y, positive 6y. If we add those together, we get 8x equals, it's going to be what, 16? So dividing by 8, x equals 2. Second part of this, we'll take our first equation, 5x, and I'm going to actually just go ahead and do this. 5x minus 6y equals negative 32. Okay, so I'm taking that first equation, but I'm substituting in the answer I found. Multiplying that, that's 10 minus 6y equals negative 32. Now our job is just to solve for y, subtracting 10. Negative 6y equals negative 42. And dividing by negative 6, y equals positive 7. So our solution is 2 comma 7. And just like before, you can plug these in, replace x with, in this case, 2, and y with 7. You should get 32. Replace x with 2, y with 7. You should get 48. And ought to make both of those equations true. Okay. Number 4. We have our 0 pair, these two right here. I'm going to go and circle those. That'll get us 7a equals 14. which means that a equals 2. Okay. Now, taking that and plugging it back into the first equation, we're going to have 3 times, it's like our two big steps here, 3 times 2 plus 4 times b equals 2. That is 6. 6 plus 4b equals 2. Subtracting 6 from both sides, we have 4b equals negative 4. Dividing by 4, b equals negative 1. All right, now we do need to write this as an ordered pair. I'm going to go ahead and write 2 comma negative 1. Okay, and as you need to, pause it, work it, write it on paper, and make sure it makes sense. If it doesn't make sense, you need to ask somebody. If it's on YouTube, there's comments. If you're in class with me, then all you have to do is raise your hand. But you need to make sure you understand this, because if you don't understand it, what's the point, right? That's our big goal, is to understand it. All right, number 5. 0 pair right here. All right, so this will become negative 1x. When we add those together, equals negative 1. Which means, dividing by negative 1, that x equals positive 1. All right, replacing that in whichever equation you pick, okay, you can use that second equation if you'd like. We can go and do that. X plus 3y. So x is 1 plus 3y equals 7. So we can subtract 1, which means that 3y equals 6. And dividing by 3, we get that y equals 2. So x is 1 and y is 2. Okay. Now number 6, we have something a little bit different. We do have a 0 pair, but it's not the same place all the rest of them have been. It's for these two right here, 5r minus 5r. 0 pair. So we get 5s equals 20. Dividing by 5, find that s equals 4. All right, so the way we've done this so far is that would go where our s is, where our y would usually go. Now we'll take that 4 and replace it for s. So we have 5r plus 3 times s equals 17. So we have 5r plus 12 equals 17. Subtracting 12, we have 5r equals 12. And dividing by 5, r equals 1. So our solution is 1 comma 4. It's a good practice to sometimes actually go back and plug these in. So that would be 5 times 1, that's 5 plus 12, that is 17. That would be negative 1 plus 8, or negative 5 plus 8, which would be 3. So it checks out. All right, number 7. Looking for a 0 pair. It looks like we have it right here with the y's. So when we add these two together, we get negative 3x equals 9. So dividing by negative 3, x equals negative 3. Okay, now let's replace that in the first equation. We have negative x, which is negative 3, minus y equals 8. So that gives us a positive 3. And subtracting 3 from both sides, we get negative y equals 5. Now, because we have a negative there, we need to divide by negative 1. Divide by negative 1, we get that y equals negative 5. So our solution is negative 3 comma negative 5. Because there's our x answer, there's our y answer. Okay, number 8. Zero pair looks to be in the x's. So that gives us a 6y, and that's negative 6. So dividing by 6, y equals negative 1. So if y is negative 1, something comma negative 1, let's plug in that value of y into this first equation. So 2x plus, well, y is negative 1 equals 3. I'm going to go ahead and write this as just minus 1. Now, adding 1 to both sides, we get 2x equals 4. Okay, now if we divide by 2, we find that x equals 2. So our answer is 2 comma negative 1. Okay, not a big deal to it. A couple more. All right, still looking for zero pairs because we're using elimination. It's almost always easier if you can find a zero pair. So here we see negative 2y and positive 2y. So adding these together, we get a 3x equals negative 9. Dividing by 3, we get x equals negative 3. There's our value of x. Now let's replace that in the first equation. Negative x minus 2y equals negative 2. All right, which using, well, that right there, that's just a positive 3. We don't have to do anything really. All right, now we can add and subtract. So let's subtract 3. So we get negative 2y equals negative 5, it looks like. Dividing by negative 2, we get y equals 5 over 2, which is 2.5. All right, now we haven't really had any fractions yet. Now, not that it's a bad thing to have fractions, but I'm going to check this one before I write that down. I'm going to have negative x, which that's negative parentheses negative 3, minus 2 times 5 over 2. Okay, and that is equal to negative 2. The first one is true. 4 times negative 3 plus 2 times 5 over 2 equals negative 7, and that's also true. Both equations are made true by the ordered pair, negative 3 comma 5 over 2. So the graph of one of these would be, it hits maybe not exactly on those grid lines, but you know it's close. It's at negative 3 and 2.5. Okay. All right, number 10 is looking for a zero pair. See one with the y's. So when we add these together, we get 5x equals positive 5, dividing by 5, x equals 1. Taking x equals 1 and replacing it in that first equation, 3 times 1 minus 6y equals 9. So that's 3. So we'll subtract 3 from both sides, which will give us negative 6y equals positive 6. Dividing by negative 6, we find that y equals negative 1. So our solution is 1 comma negative 1. Okay. Next two, zero pairs. We have a zero pair in the y's right here, which will give us, when we add these together, a negative 3x equals 15. All right, so that's negative, divided by negative 3, we have x equals negative 5. All right, replacing that negative 5 in the first equation, we have negative 5 plus 2y equals negative 2. Adding 5 to both sides, we'll get 2y equals positive 3, dividing by 2, y equals 3 over 2. And why not go ahead and check this one. X is negative 5 plus 2 times 3 over 2 is -2. And -4 times -5 minus 2 times 3 over 2 is in fact 17, and there's our answer. Number 12, our zero pairs in the y terms. So when we add these together, we get positive 8x equals 4. Dividing by 8, x equals 1/2. All right, so if x is 1/2, we'll replace it in the original equation. 10 times 1/2 minus 3y equals 5. That's 5. So we have 5 minus 3y equals 5. Subtracting 5 from both sides, and we get a 0 pair over here, 0 over here, so -3y equals 0. Dividing by -3, we find that y equals 0. So our solution is x is 1/2, comma, y is 0. All right. Number 13. 4 pencils and 2 pens cost $6. 6 pencils and 5 pens cost $12. Which system could represent the cost of a pencil and the cost of a pen? So x is pencils, so we have 4x and 2y equals 6. Okay. Only one that is looking good so far is C. 6 pencils, 5 pens, $12. So yes, it is C. Okay. We had this happen with word problems with linear inequalities before, if you remember. The numbers that go with those variables just go as coefficients. All right, so next, Ellen is having a party and wants to make mixed nuts. Peanuts cost $2 a pound, and cashews cost $4.50 a pound. Okay. And let's see, P is pounds of peanuts and C is cashews. So 2P should be in there somewhere. Okay, and that is not B. Okay, now 450 goes with cashews, so 450C, 4.5C. And we have a problem here. There is no decimal on this one right here. There's no decimal, so C is out. And then that should be $24. So D is out. Okay, so equals $24. And then we have, she wants to make 7 pounds. So that means C plus P, if you add them together, you get 7. So therefore, that is, in fact, A. All right, number 15. On Monday, Logan had 2 hot dogs and a carton of milk, totaling $2.85. On Wednesday, he had 3 hot dogs and 2 cartons of milk, totaling $4.45. Which system best represents the situation if H is the hot dog, cost for a hot dog, and M is the cost for each carton of milk? So 2H plus 1M is 285. So let's start there. 2H plus 1M equals not 285. 2H plus 1M equals 285. 2H plus 1M. 2H plus 1M, no. Answer is B, because now 3 hot dogs, 2 cartons of milk is $4.45. All right, number 16, last one. There were 411 people at a play. Admission was $1 for each adult and 75 cents for each child. The receipts were $395.75. That means the total cost. Write a system of equations that will determine how many adults, A, and how many children attended the play. Now we just need to write the system of equations. We're not solving it. We might do that tomorrow. All right, so first we know that adults are A, and we know that the cost per adult is $1. We know the cost per child is 0.75, and the total amount that was brought in was $395.75. Okay, there's one equation. Next thing we're told is that there were 411 people at the play. 411 people total. So that means if you put the adults plus you count the children, you should get $411. And that is our system right there. All right, now remember, our big goal is 0 pairs. Find the set, whether it's the x or the y's, that has the 0 pair in it, and go from there.